So good day everyone. We are here to discuss about the special purpose system. So introduction. An operating system is the most important software that runs on a computer. It manages the computer's memory, processes, and all of its software and hardware. So it also provides to communicate with the computer without knowing how to speak the computer's language. So without an operating system, a computer is useless. So additionally, an operating system also acts as an intermediary between the computer user and the computer hardware. So it provides an environment in which a user can easily interface with the computer to execute programs. So also some operating systems is designed to be convenient, others to be efficient, and others is the combination of the two. So let us talk about now the parts of the special purpose system. So what is special purpose system? A special purpose system is a system or platform that employs computing resources, hardware, firmware, and optionally software that are physically embedded in, dedicated to, or necessary in real time for the performance of the system's mission. So there are three parts of the special purpose system, namely the real-time system, multimedia system, and handheld system. So a real-time operating system or embedded operating system is a computer operating system designed to handle events as they occur. So real-time operating systems are commonly found and used in robotics, cameras, complex multimedia animation systems, communication, and has various military and government uses.
Characteristics of real-time systems are large and complex, have concurrent control of separate system components, have facilities to interact with special-purpose hardware, mixture of hardware and software, extreme reliability and safety, and guaranteed response times. Some examples of real-time systems include industrial robots, GPS receivers, digital cameras, DVD players, wireless routers, MP3 players, set-top boxes, gaming consoles, photocopiers, and microwave ovens. Real-time systems are classified into three. First is hard real-time system. Examples are flight control systems, automotive systems, and robotics. Second is soft real-time system. Examples are banking system and multimedia. And the last is firm real-time system. Features of real-time systems. Most real-time systems do not provide the features found in a standard desktop system. The reasons are that real-time systems are typically single-purpose. Next, real-time systems also often do not require interfacing with a user. The features found in a desktop PC require more substantial hardware than what is typically available in real-time system.
Next is the multimedia system. The operating system provides a comfortable environment for the execution of programs, and it ensures effective utilization of the computer hardware. The operating system offers various services related to the essential resources of a computer: CPU, main memory, storage, and all input and output devices. The integration of discrete and continuous multimedia data demands additional services from many operating system components. So the key to multimedia operating system is the real-time processing of the continuous data.
Hi, so I'm going to discuss the characteristics of multimedia system. As we can see in the previous slide, multimedia system provides a comfortable environment for the execution of programs. So, the characteristics of multimedia system showcases unindulged characteristics. The first characteristics of multimedia systems is more default tolerant. The next one is deadlines tend to be soft because it provides a free environment for the execution of programs. The third one is schedulability consideration is much easier. And the last one is bandwidth requirement is not always stringent. First, what is bandwidth? Bandwidth is the amount of data transmitted in an application. So now, let's talk about the resources management. Resources management, it is where the nature and the source of the application begins. Multimedia systems with integrated audio and video processing are at the limit of their capacity, even with data compression and utilization of new technology. No redundancy of resource capacity can be expected in the near future. In a multimedia system, the given timing guarantees for the processing of continuous media must be adhered to along the data path. The actual requirements depend on the type of media and the nature of the application supported. And the shortage of resources requires careful allocation, and the resource is first allocated and then managed. Now, the next topic is the requirements of resources management. The requirements of multimedia application and the data streams must be served. The transmission or processing requirements of local and distributed multimedia application can be specified according to the following characteristics.
Throughput, delay for local, end-to-end delay for global, jitter, reliability, how the application handle errors, and the retransmission may not be acceptable for critical data. Multimedia refers to data of multiple types that includes audio and video, including conventional data like text files, word processing documents, spreadsheets, etc. It requires that audio and video data must be processed based upon certain time restriction. This is called a streaming. It is usually 30 frames per second for a video file. Applications such as video conferencing, movies, and clips downloaded over internet, MP3, DVD, VCP, playing and recording are examples of various multimedia applications. A multimedia application is usually a combination of both audio and video. The multimedia is not limited to desktop operating system or computers, but it is also becoming popular in handheld. Next, here are some examples of multimedia operating system. One is chemical plant, where it is used to receive measurement from the furnace, compute the adjustment, and send the adjustment to execution. Another example is the video playback system, where it reads the data from the DVD, decoding and formatting, then sending it to frame buffer.
Handheld system. Handheld is a small computer packet-sized computing system, or handheld is any portable device that can be carried and held in one palm. Developers of handheld systems and applications face many challenges, most of which are due to the limited size of such devices. Because of their size, most handheld devices have a small amount of memory, slow processors, and small display screens. The amount of physical memory in a handheld depends upon the device, but typically it is somewhere between 512 KB and 128 MB. Contrast this with a typical PC or workstation, which may have several gigabytes of memory. As a result, the operating system and application must manage memory efficiently. This includes returning all allocated memory back to the memory manager when the memory is not being used. A second issue of concern to developers of handheld devices is the speed of the processors used in the devices. Processors for most handheld devices run at a fraction of speed of a processor in a PC. Faster processors require more power. To include a faster processor in a handheld device would require a larger battery, which would take up more space and would have to be replaced or recharged more frequently. Most handheld devices use smaller and slower processors that consume less power. Therefore, the operating system and application must be designed not to tax the processor. The last issue confronting program designers for handheld devices is I/O. So, the example of handheld systems are the personal digital assistant or the PDAs. A PDA is typically about 5 inches in height and 3 inches in width, and it weighs less than 1/2 pound. Cellular phone or smartphones, Linux, Windows Mobile. The special purpose of handheld device is it increases in speed and smaller size of memory. The characteristics of handheld systems are the data entry, transferring data using Palm Pilot to conduct surveys and inventories in libraries. The design of handheld system. The design criteria are by location, by call or accession number range, by collection, by format or type, by usage or exhibition, by date added to the collection, by preservation or conservation project.